Our last video regarding classification has to do with applying filters. In some cases, certain values or characteristics cause our data to be skewed in one way or the other. That is, for example, there are outliers or negative values that we don't want to include. And so what we're going to use in this case is a filter application, and that exists for each one of the features that we have. And so what I want to do though is talk a little bit about kind of the reality of working online. When you apply filters in ArcGIS Online, two things are going to happen. First of all, you have to accept that you're working online, so some things are going to be a little bit slow. The other thing is that sometimes you'll have to change an attribute or a classification and then change back to get the filter to apply. So again, what we're going to do here is, in our previous video we noted that Washington DC is to some degree an outlier. We're really looking at a state level data, and we really shouldn't think of Washington DC as a state. It has a population density far in excess of any other state, over 10,000. And so it really kind of causes problems with our data classification. So what I want to do is we're going to click on our feature class, in this case 2016 U.S. population density, and then we're going to note we're in states as the active level, and we're going to click on the filter options. First time we've used that. So click on filter, and what I'm going to do is I'm going to select the state abbreviation, and I don't want it to be DC, so I'm going to choose is not as my logical operator. And then in order to make sure that I get the right value in there, I'm going to click on this unique option here, and what that will do is give me a list of all of the options within that field. So the first part is the field in the attribute table, the second part is our logical operator, and then the last part here is how we want to look things up. So I'm going to again click on unique. We do that when we have relatively few values. If we have 1,000 values or 5,000 values, obviously we don't want to use that, because it will create a very long list. But in relatively few, this works. So again, I'm going to choose unique, select the drop down, and I'm going to scroll down to DC and select it. Now the next thing I need to do is hit apply filter. Click on that. And you'll notice that nothing really changes. Well, the problem is that, one, we need the system to kind of get caught up with the filter that we've applied. So in order to do that, what I'm going to do is select again my drawing options, and you'll notice that right here that number is in fact Washington DC, so it appears to still be in our classification. But if I go to the options now, and you notice again it's still here, and it's causing that long skew or long tail to the high values. But all I really need to do is change my classification then to our equal interval, and you'll notice that that value drops out. Now we'll notice that our classifications don't go all the way up to 10,000. In fact, they only go up to 1,225. And so now it's a little bit easier to work with our data. Even our equal interval, which is really not an ideal classification for this, shows more data now. But now what I'm going to do is select, in this case, the natural breaks option. And we'll notice that, in fact, again, our data range is a little bit more manageable. All of the states appear, and I'm going to click OK and done. And now in our legend we have the range of values right here that are appropriate for all of the states, and we've excluded Washington DC. I want to show you again how that appears then in the filters. So we're going to go back to content and back to our population density. And when I now click on filter, you'll notice that that filter is there. State abbreviation is not DC. Now I can get rid of that filter by simply clicking remove, and that will put that data back in to our data set. I could, in theory, also add an additional filter to that by clicking edit, and we might say, for example, not DC and greater than a certain value. Be one way of doing this. Okay, so that's using filters to constrain our data, or to limit, in a sense, what is used or visible within our classification.